As I look at this series and think about convergence tests, I see this 3 to the n over 4 to the n, and if I had 3 to the n over 4 to the n, I could express that like this, and I see that that is a convergent geometric series because the common ratio here is less than 1. So I'm thinking of some kind of comparison test, but with these other terms here it's a little hard to do a comparison, so I'm just going to do a limit comparison test. So I have the limit as n goes to infinity of 5 plus 3 to the n over 2 plus 4 to the n. And so then I am going to divide that by 3 to the n over 4 to the n. So setting this up for our limit comparison. Now I'm going to flip this over and multiply, so I have 4 to the n over 3 to the n here. So if I combine those, I have the limit as n goes to infinity of 5 times 4 to the n plus 12 to the n, and that's 12 to the n because it's 3 to the n, 4 to the n, and I could take that then and make it 3 times 4 to the n. Now in the denominator I have 2 times 3 to the n plus another 12 to the n. So looking to see how I'm going to evaluate that limit, I'm actually going to multiply numerator and denominator by 1 over 12 to the n. 1 over 12 to the n. So we'll come down here and have the limit as n goes to infinity of, when I multiply that here, I'm going to end up with 5 over 3 to the n because I have 5 4 to the times 4 to the n, and then 12 to the n is 3 to the n times 4 to the n, and those would cancel. And so then I have plus 1, 12 to the n over 12 to the n, and then that's going to be over 2 over 4 to the n plus 1. Same kind of thing here. The 3 to the n piece cancels and leaves me my 4 to the n. Now as we let n go to infinity, these two terms go to 0 and we get 1. So we ran a limit comparison and we got the limit is 1. And so our requirement was as long as the limit was positive and finite, which it is, then whatever our comparison series does, that's what this series does. And our comparison series was this geometric series with the r less than 1, and so this series converges.